So let's first start off with discussing what converging lenses are. So converging lenses are going to be those lenses that are going to be refracting light inwards. So when we have these parallel light rays, we're going to be refracting light inwards. And the position of our image really sort of determines what kind of image is produced. So what I mean by that is, let's start off with our image over here and draw our ray diagrams. So usually when you're starting with ray diagrams, you want to start from the top of the image, then move parallel because our light rays will be parallel. And once we get to our converging lens, then we want to penetrate to the focal length over here. And just as reference, our eyes, or what we're going to be seeing as the image that pops up, will be over here. So any of the image that we will see will be on this side. Now over here with our next ray, we need to take the top over here and go through our focal length from this side of the converging lens. Stop at the middle, and then this is when we refract the light. And where these two rays cross, this is where we produce our image. So the image that we will be producing, let me copy paste this. The image that we will be producing will be real, inverted, and since this is far away from the focal length, this will actually be reduced. So as you can see, we have a real, inverted, reduced image. So I'm going to be writing this in orange. We have a real, inverted, and reduced image. And this is actually one of the images that will be formed with our converging lens. And this is when we're out of the focal length. Now that we have that down, let's try actually moving our image a little bit closer. So let's say we put it in between these two focal lengths of two focal lengths and then our regular focal length. So same thing with our ray diagrams, just drawn from the top, going parallel until we get to our converging lens, then going through our focal length over here, goes through there, and then we're going to have same thing over here, but going through our focal length down here, be a little bit steeper, and then moving straight. So now we actually have the same thing. We have a real inverted image, but this will actually be an enlarged image, as you can see. So where these 2 points meet, this is where we form our image. So when our object or our image is between our focal lengths, when we move it closer and closer to our focal length, we are going to be creating a real, inverted, and enlarged image. Over here. Now, what if we move our image even closer past our focal length, closer to our converging lens? What would happen then? Well, let's take out our ray diagram over here. I'm going to have to just leave this over here. Delete that. And now let's move our image closer all the way over here. Well, the easiest part might be, doing our ray diagram from the top and moving parallel. And this goes all the way down. We could just move it down over here. But now this is when we're going to be creating what's known as a virtual image. So a virtual image is going to be an image that isn't really there in a sense. So we'll go through a PhET simulation just to sort of show that, but it's as if you got a lens, like for example, you have your converging lens and you see an image in that lens, that is a virtual image. It's like there's something in there. Or for example, if you're looking at a mirror, when you look at a mirror, it looks like you're in that mirror. Like there's someone else in that mirror, there's other objects in that mirror, but that's a virtual image. It's not real. So that is what our virtual image is going to be. And over here, this is where we create our virtual ray. So we're going to start from this focal point all the way over here, then move up right here, and then this will move parallel. And the image that we will be creating is where these two ray diagrams will converge in our virtual image. So let me change this guy to this, and let me move this right over here. So this is going to be that ray. This is going to be this ray right here. And this, where both of those rays converge, this is where we create our virtual image. And as you can see, our virtual image is going to be upright. It will not be inverted. So a mnemonic you could use to memorize the fact that when you have a virtual image, it will be upright. Real is inverted is UV and IR. So upright, virtual, inverted, real. So that's a little mnemonic you could memorize. And as you can see, with our virtual image, it will actually be enlarged. So what a converging lens will do when we're closer, when we're beyond the focal point, closer to our converging lens, we'll be creating a virtual, upright, and enlarged image. So just to summarize, with our converging lens, we're going to be creating real inverted reduced, real inverted enlarged, and virtual upright enlarged images. All right, so now let's talk about our diverging lens, also known as our concave lens. And this lens will be bending light outwards. So how do we draw ray diagrams from here? Well, we're obviously going to be using our parallel rays, so we got to draw that first. And over here with our focal length, we're going to be bending light that's towards the angle of the focal length. So we could think of this as imaginary over here, because we know that our diverging lens will be bending light outwards. So it might be sort of at this angle over here. And we'll have a ray that will just go straight through our diverging lens right over here. And where these rays converge, that's where we create our image. So let me copy paste this guy over here. This is where we create our image. And as you can see, we have created a virtual, upright, and reduced image. So this is the type of images that diverging lenses will create, is these virtual, upright, and reduced images. So here's that PhET simulation I was talking about. And as you can see, when we're beyond the focal length over here, so if I push my focal length all the way over here, we're creating a real inverted but reduced image. Then as we get closer, our image gets larger and larger. So this is still real, inverted, and it's going to get enlarged until we get past our focal length, closer to the converging lens. And this is where we create our virtual, upright, and enlarged image. Now with our diverging lens over here, however we move our image, we're creating a virtual, upright, but reduced image right over here. So now let's talk about the science behind your eyes and how farsightedness or nearsightedness can affect the images that you see. So let's first start off with myopia, also known as nearsightedness. So this is where people like me, we can't see things that are far away. We can see things that are close, like if we wanted to read a book, for example, we might be able to see that very well, but we can't see like the road in front of us or like cars in front of us. Things are a little bit far away. Those are things we can't see. So what happens in our eyes over here, so our lens over here, this is our lens, and the cornea is over here, conjunctiva is this thin layer over here. But our lens is going to be a converging lens in our eye. And in myopia or farsightedness, we're going to have these parallel light rays. So obviously they're going to be parallel. So I'm just going to be copy and pasting this guy over here too. So these are going to be parallel. But the thing is, when they converge, so they converge over here, they converge in front of our retina. So our retina is over here. Our retina is where we need to have that focus point. So when objects are far away, our focal point over here, they converge ahead of the retina. So how do we correct this? Since if we have a lens that is projecting or converging our light, our images ahead of our retina, how do we push this guy sort of ahead so we can actually see the image properly? How can we do that? Well, this is where we bring in a diverging lens, and these are what most of our glasses that we use, like if you see someone regularly wearing glasses, these are going to be our diverging lenses. Like me personally, I wear contacts, so my contacts will be a diverging lens. And what happens is, as we know, our diverging lens is going to be bending light outwards. So let's have our light ray over here, light ray over here. Let me actually move this a little bit downwards, a little bit closer over here. So we have a light rays over here. They will be bending light outwards over here to our converging lens, so we're bending light outwards. So then this allows our converging lens to allow these light rays to converge at our retina. So now we can actually see the image. So if a car was far away from me and I put my glasses on, now I can see that that car is actually right in front of me. So this is how we solve nearsightedness or myopia with a diverging lens. So the opposite of this is farsightedness. So let me actually draw that now. So farsightedness is when we're going to be having these, obviously we're going to have these parallel light rays that are going into our lens over here, our converging lens, but then they will go past our retina. So this is, for example, when, our parents might need reading glasses, is because they can see things that are far away. That's no problem for them. But when they're reading a book or, looking at the screen of a computer or something, they're not able to see those images because the image is projected beyond the retina, past the retina. So how do we correct this? Well, this is when we need our converging lens. And our converging lens, I'll leave that there. Our converging lens, and we'd bring it out over here. We'll still have those light rays going through our converging lens, but then we're going to be bending, and let me actually create a little bit of separation in this guy over here to make it a little bit more pronounced. So we know our light rays or our converging lens is going to be bending light inwards, so we're going to be bending over here, So that way, these rays can actually converge ahead of the retina, on the retina. And this is where we create that focused image. So this is where our reading glasses come into play, is that they create our converging lens from those reading glasses will allow us to see that image. So they'll allow our parents to read the book or, go around Facebook and see what's going on.